an example here. So if I say negative 3x squared times 2x squared minus 3x plus 5. Okay, that's what I kind of showed you how to do that once already. What we do is we use the distributive property, and we're going to push that 3x squared through each term. And I even showed you like a grid method to make sure you don't forget. Because one of the things about the distributive property is that when we push each term through, okay, when we push each term through, sometimes we forget this term or the last term, but sometimes we skip a term. So what I suggested is using some sort of grid. So if I take a grid, now see this is one term and this is 1, 2, 3 terms. So I'm going to say 1. I'm going to draw mine a little big. You don't have to be this big, but I want everybody to see how we do it. I'm going to put my negative 3x here, negative 3x squared, and then each of these terms I'm going to write above here. So this will be a positive 2x squared, right? Negative 3x, and then a positive 5. And so what we're going to do is we're going to multiply the row by the column. Okay? So essentially, the answer that I'm going to put in here is just going to be negative 3x squared times 2x squared. So we're just multiplying the row by the column. Let me zoom out a little bit so you guys can see the whole thing. I'm multiplying negative 3x squared times 2x squared. Now the way you do that is you multiply the number by the number and then the variables by the variables. So what's negative 3 times 2? Negative 6. All right, now what's x squared times x squared?
X to the third.
X to the fourth. How do I get 4?
Oh, 2 and 2.
Yeah, we're going to add this and add this. So that becomes x to the fourth, right? See what I'm doing? So now for the next one, we'll draw this down a little further. What I'm going to do is I'm going to still multiply by negative 3x squared. And then I'm going to multiply that by what? Negative 3x. So we do the numbers first. What's negative 3 times negative 3?
Positive 9.
So we're going to have a positive 9. And I'm going to put the little positive sign in there. And then x to the third, right? Because this is a 1. We didn't write it down, but 1 plus 2 is 3. Nice. All right, so now what do we do here?
We multiply.
What am I multiplying here?
Negative 3x squared, same thing.
Negative 3x squared
5, positive 5.
times a positive 5. So now what's that answer going to be?
It's going to be negative 15x squared.
Negative 3x. Negative 15. And you just write it out.
You do the
negative.
What's negative 3 times 5?
Negative 15.
Negative
carry
15.
your x squared.
Okay, now I'm going to pause right there. Does anybody have any questions on how I did that?
No.
Yes, what's your question?
When it okay, so when you actually write out the negative 3x squared, it's basically saying there's negative 3x, like the actual x is there, right? If you draw it out. So how come you would still multiply it even though there's no x there? Yeah.
Oh, because like terms is only for adding and subtracting. When you multiply, you just multiply. Okay? So the question was, hey, these aren't like terms. How is it that we could just multiply them? Well, multiplying, really what we're doing, and that's a great question, and let me answer that. What I'm really doing is I'm saying, okay, I've got negative 3x squared. Remember, multiplication is the shortcut for addition, right? So 3 times 4 is 12, but isn't that really saying 4 plus 4 plus 4 3 times? Okay, so what I'm really doing, this right here is really how many times am I going to add this? 5 times, right? And we'll put one right in the front. I drew my numbers a little too big. Okay, so now when I add up all those negative 3's, what am I going to get?
You're going to get negative 15x squared.
Negative 15, but now the x squareds are just, that'd be like saying I got 1 marker in my hand, now I have 2 markers. I could say I have 1x squared in my hand, 2x squared, 3x squared, so I got negative 15x squared. Okay? So now what's my answer to this multiplication problem?
Negative 6x to the 4th.
All this stuff right here,
Yeah.
right? So this is equal to, and we'll write the answer in purple, when I push this through, it becomes negative 6x to the 4th, positive 9x cubed, negative 15x squared. That's my answer. Okay? Does that make sense? Yes?
So like in this one it like already had it lined up perfectly. Would we move it around to line it up too? Like from biggest to smallest?
Biggest to smallest, you could do that. But you know what? If you line them up like this is already in descending order, that's a practice that we do so you know that there's an order, but most of the time the stuff will be in order. But yeah, you can, if you line it up here, then it'll automatically line up here. But you could wait till the end and line it up. The question was, do we put it in descending order every time, and you know, do we have to? And so he noticed that it was already in descending order. Yeah, we should always make sure that it's in descending order. It just so happened that this one was rigged up. And most of your homework problems will be rigged up that way. Okay, so now let's do something a little more complicated. Can I move on to the next example?
Yeah.
Okay. So now for my next example, I'm going to say negative 3p times 2p squared minus 4p plus 7. Okay. Then over here I'm going to say minus 5 times p squared minus 3p plus 2. Now there's some work that I could do there. What do I want to do? Yes.
You want to break them up into into separate equations?
Yeah, so we're going to distribute. Well, we don't want to break them up because we're going to put them all together, right? So we could do the grid method here again. So I'm just going to leave them all one color. This is going to be 3p times 2p squared minus 4p plus 7. And I'm going to put the plus sign so I remember to get the signs right. So now this is going to become negative 6p to the third. This is going to become 12p squared. And this is going to be negative 21p. All right? So by pushing this 3p, this negative 3p through every term in the parentheses, I'm going to end up with negative 6p cubed plus 12p squared, right? And then minus 21p. Okay? And double check the math as I go through that. Now for the second expression, again what I'm going to do is I'm going to push this negative 5 through. Okay? So I'm going to say negative 5 times the quantities, p squared, negative 3p, and then positive 2. And so that's going to be negative 5p squared, positive 15p, and then negative 10 by multiplying the row by the column. Yes?
How did you get 12p to the second power?
What's negative 3 times negative 4?
12.
Positive 12. What's p times p?
Oh,
P squared. Good question. Good question. All right, so now when I push this 5 through, I'm left with negative 5p squared plus 15p minus 10. So I distributed the negative 3p through the first set of parentheses and then the negative 5p through the second set. And when I push it all the way through, these are all the terms I get. Yes?
Do I have to combine like terms?
Yep, that's the next step. The question was, should we combine like terms? Yes, we should. Absolutely. So, 6p cubed is the only p cubed, but I noticed that I have a 12p squared and a negative 5p squared, okay? I also noticed that I have p to the first power and 15, another p to the first power. And then the negative 10 is a constant. That's all by its lonesome, okay? So what I'm going to do now is I'm going to rewrite the whole equation. So I'm going to say negative 6p cubed. And then I'm going to write this extra step so you can see it. Plus 12p squared minus 5p squared. Okay. Then I have negative 21p. And then plus 15p. Right? And then I have negative 10 tacked on the end. Now, when you do work like this, if you're doing it in a hurry, there is a tendency to miss a term or forget writing down a term. So one good practice is, look, I've got 1, 2, 3, 4, 5, 6 terms. If I did the grid method, I should have 1, 2, 3, 4, 5, 6 terms. I used the commutative property of addition to rearrange them so I could clearly see what the like terms are. To make sure I didn't forget a term, I should have 1, 2, 3, 4, 5, 6 terms. So I didn't forget anything. Yes?
So when you put it in that order, do you still like combine them like 12p negative?
Yeah, we're going to combine them, but I just wanted to make it crystal clear that we knew what the like terms were. All right? These green ones are p squareds. These purple ones are p's, and then these two are just in orange because they don't have any like terms. They're already simplified, right? So now what that means is I'm going to combine these and then combine these, and those are my like terms that I'm going to combine. Does that make sense? All right, so let's do that. So now I've got negative 6p cubed. What's 12 minus 5? Positive 7p squared, right? And then what is negative 21 plus 15?
Negative 6p
Negative 6p.
minus 10.
And then minus 10 tacked on the end, all right? And then since I can't simplify it anymore, that's actually my answer. So, all this stuff here, after I've distributed it, becomes negative 6p cubed, I'll zoom out in a second, 7p squared minus 6p minus 10. And so you might say, well, Mr. Adams, why would we do that? Well, remember I said that sometimes we'll have equations that represent things. This might be the equation for making skateboard wheels, right? And this might be the equation of the cost of the material that we need for the wheels that we have to pay out. So whatever this is, or this, you got two equations or two expressions. You know that you're going to do the same thing every time. So you just combine the expressions and come up with one, which is a little easier to do. Does that make sense? It could be anything that you want to plug in. All right. Any questions on this stuff?